This is lesson 5, day number 4. We're going to pick up with our square root stuff and continue here, but we're going to mix it up. What we're going to do today is we're going to take the square root of -1. Happens to be we don't like to take square roots of negatives. And so what I would like to affectionately say, well, you need to poke an eye out. So when you square root a negative number, you will have i's in there. I is for imaginary numbers, because technically if you have a calculator and you say, what's the square root of -1? It will say air. It's not a real solution. It's not a real number anymore. So now we're venturing into the non-real, so the imaginary side of things, like Seth's friends. And so...
Yeah, Mr. Contract, we're wearing a shark costume.
Yes, but they can't see that in the video.
Well, here, let me take a picture.
Now, what we have here is, to simplify our problems, is that they have it so that the square root of -1 is equal to I. Okay? I. I is the square root of -1. And if you remember, what you do to one side, you do to the other. So I can multiply it by 2, I can multiply it by 3, divide by 4, so forth. But I can also square both sides. Which means if I square I get I squared. Yeah? And if I square a square root, they cancel each other, it equals -1. So I squared is equal to -1. Guys, this is very important. You need to know that I is equal to the square root of -1, and that I squared is equal to -1. It's important that you know those, make sure they are in your notes. Hence, I put the little fry symbol on there, because we all like fries, we should all like these as well. Now, the next thing up is complex standard form. Complex standard form, guys, hint, everybody, or not everybody, every number can be written in complex standard form. Complex standard form is A plus B I, where A is your real number, so your real component, and the B part is your complex component. Now here's the thing. So, 2 plus 3i, that is a complex number in complex standard form. 5i is also a complex number. If I had to truly put this into complex standard form with an a and a b, well, b is 5. What's a? Because this is technically in standard form. What's the a value? What's the real part of this problem? Is there anything there? And if it's not there, it's a 0. So it would be 0 plus 5a. Guess what? 7 can be written in complex standard form. 7 is a real number. What's missing? The i's are missing, right? So therefore, it would be 0 i's. So 7 plus 0i. So all numbers, real or imaginary, can be written in complex standard form. Okay? The last thing I want to talk about, and I'm hoping you guys would have done it last year, when you guys should have been introduced to this as well, is that I could technically graph those. I'm actually going to make this a little bit larger. I can make this into graphs. So I can, looks like everything's positive, I can graph 2 plus 3i. So instead of talking about this as a standard xy plane, they put this as a real and then the imaginary. So the real part is your x, that's the a values. The imaginary is the b value, and that goes up and down. So if I wanted to plot the point 2 plus 3i, I go 2 over and 3 up. So that is that point. 0 plus 5i is where? Straight up. 5. 1, 2, 3, 4, 5. You guys get this? 7 plus 0i is to the right. 7. 1, 2, 3, 4, 5, 6, 7. There we go. Okay, that's how you would graph them. It will be important when one of our later lessons in the year, you're going to be asked to graph this so we can change forms. We're going to be able to find angles. We're going to be able to do a lot of different things after we learn some trig identities, some really cool information to help us kind of understand numbers a little bit more. Now, we have to do this problem. I have to simplify this thing. Do you guys notice that there are a bunch of things with i's in it? Number 6 here. I've got 3i cubed plus 2i to the 5th minus 3i plus 2i squared. My goal is to make it look like this form, which is a plus bi. So, I'm going to give you guys a rundown of how to make this go a lot easier. I don't do all of this in my head. I break it down into steps. Step number 1. Think of what does it mean to have a power? What does it mean to be I cubed or I to the 5th or I to the 10th? Anything to the 3rd, or 10th, or 5th. Multiplying to itself that many times. You guys agree with this?
Yes.
Okay. So that means I have 3 I. That's 3i cubed. Everybody with me on that one?
Yeah.
I'm going to do that for every single one. I'm going to break it up. I'm going to break it down. 2, so 1, 2, 3, 4, 5. Got 5 of them. Minus 3i, and then plus 2i. So everybody, I broke it down to the number of i's that the power has. Good?
Yep.
Now wait a minute. Let's go back to the top of this page. In the top of this page, you have I squared equals negative 1. So if I see an I squared, I can replace it with negative 1. But isn't I squared I? So every time I see an I can replace it with negative 1. So, step number 1, break it all up. Step 2, I want you to go back and I want you to circle up pairs. Okay, I have an I. Eventually that I will become what? I becomes negative 1. Go into the next group because there's not another I here. You see that? He's left over. So, okay, I. Does a 3 have any groups? No, but the 2 has a group. Okay? So, step 1, break it up. Step 2, circle up your partners. Step 3, I'm going to go back and rewrite everything, but the circled groups will now become a negative 1. So, I have 3 times negative 1i. I'm putting parentheses around that negative 1. It's very important. I'm using substitution. When you use substitution, you use parentheses. 2, this first I becomes negative 1. Another negative 1. And again, I left over. Yes? Not changing anything on the negative 3i. And then it becomes 2 times negative 1. Does everybody see that I just retook all of the groups that I had and changed them with parentheses to a negative 1? Now start cleaning it up. What is 3 times negative 1i?
Negative 3i.
Negative 3i. What does 2 times negative 1 times negative 1 times I. Two negatives make a, so it's 2 times 1 times I. It's a positive 2I. Minus 3I, because nothing's changing. And what's 2 times negative 1? Minus 2. Do we have any like terms? We have i's. You have a negative 3 of them plus 2. So you have negative 1. And negative 1 minus 3? Negative 4i minus 2. So you've gathered it all up. It's all grouped together. Everybody finding that? Seeing that? The only thing is that that is not in complex standard form. How would I change it up? It'd be negative 2 minus 4i. And you now just simplified this complicated looking expression. So, steps. Break it up. 2, circle it up. 3, replace. 4, multiply / simplify. 5, gather up like terms. You should not have anything but real numbers and imaginary numbers, or some mix of them, right? You're not going to have I squared anymore. You're not going to have I to the 4th power anymore, or I to the 20th. Okay, guys. This one is kind of like problem 6, as in you're going to have some i's that you have to put together. But it has some other things. In the beginning, I told you guys cannot take a square root of what? A negative number. So, when you see a problem like this, the first thing you need to do is poke an I out. That's number 1. Number 1, you need to poke the I out. Which means take the negative from the inside and kick it out by poking it out. Does everybody understand what I'm saying? So let's practice this. The first one is a square root of negative 3. I don't like negative 3. So I'm really technically going to say that's a square root of 3i. Because negative 3 is really 3 times negative 1. And if they're multiplied inside, can I square root both of them? And what's the square root of negative 1? I. Guess what? Square root of 4 is going along for the ride, isn't it? Plus 3. What's next? Square root 2. And then i's on the outside. Make sure you do not put the house of the radical over the i's. Next. Square root of 9. I. Plus square root of 16. I. And then actually this one, square root of 16 is 4. I might as well just clean it up because I'm going through a first round. Now, let's take a look at what you can clean up. Looking at the first group, can I clean any of that up? The 4. Square root of 4 is 2. So guess what? We can actually change the first one to 2, square root of 3, and the I goes on the back. I personally like to put i's at the end, and I kind of make it obvious that it's not inside the radical. There are some books that will put the i's right in front of the square root, so you'll never get it mixed up. Okay? So be careful on that. Plus, what does this clean up to be? A 3, right? 3. And then there's already a 3 out front, so this becomes
6.
9. square root of 2, what? How many i's are there? 2. And square root of 16 is? So that's 4i plus 4. Hey, wait a minute. I have a group of 2 i's, don't I? So I circle them up and it becomes a -1. So now, would it be okay if I keep everything else the same, but instead of adding 9 square root of 2, I'm going to subtract, because the -1, which I kind of put right underneath, times 9 is -9, plus 4i plus 4. Yes or no?
Yeah.
I now need to put this in standard form. That means the real stuff goes first, and then the i's go last, right?
Yeah.
So let's just rearrange. Isn't this -9 square root of 2 plus 4? That's my real parts. And then the imaginary parts go at the end, which is plus 2 square root of 3. I'll make that better. 2 square root 3 plus 4i. Oops, that's an I in there. After the square root of 3. Did everybody see I just kind of rewrote them together? Kind of group-like things together. Real stuff, imaginary stuff. Guys, again, I need to do this. I need to put it in a plus bi form. Here's the crazy thing about this, guys, is that a, which is the real thing, is all of this. It's -9 square root of 2 plus 4. That is a. You could take a calculator and you could give me a decimal for it if you wanted, but that's the exact answer. B. What's B? It's not both of them, because guess what? There's only plus bi. B has to be a number and I has to be at the end. What do both of these have? They both have a what in them? Right there. What is that? It's an I. If they both have it, can I take it? AKA factor it? I'm going to leave this alone because that is A. But can I factor I out? What's left with 2 square root of 3i if I take the I? What's left? If I take the I out, it's 2 square root of 3 plus 4. That is the answer that you guys should be providing. Because this is A and that is B. Again, you could take a calculator and convert that to a decimal, which is an approximation, but that is the exact answer. Now, could you have, for this part here, 4 minus 9 square root of 2? Yes, it's just a different order, but they will give you the same value. Next up, guys, we're going to do this scale factor thing again. Okay? Here's a really cool thing about that similar triangles, similar shapes, guys, is that the blank of the areas of similar 2D geometric figures equals the blank of the scale factor between them. Guess what? The scale, the ratio of the areas of 2 geometric figures equals the square of the scale factor. Okay. And we're going to show you why this works. And this is actually cool. We have the small rectangle and I have a larger rectangle. For all intents and purposes, I am telling you they are similar, even though they may not look like that. The scale factor between these two rectangles is 4. Or, if you want to say, it's 4 over 1. 4 to 1. Find the ratio of the areas. Well, let's take a look. If they are similar, if you remember what similar means, that means their corresponding sides have that same ratio. 4 to 1. 4 to 1. 4 to 1. So if I call this W, what is this with? This is the bigger one. It has to be 4 to 1. So if this is W, what's this one?
L.
Can't be L.
W.
It's not just W. It's definitely bigger. It says by a factor of 4. Scale factor is 4.
W4.
W4 or 4.
W.
Guys, it's 4 times larger. Scale factor. 4 times larger. 4 to 1. It's that whole similar triangle thing that we did on the last quiz is. If this is L, then what does this have to be then?
4L.
4L. Thank you.
Hang of it.
Yeah, okay. Starting to get the hang of this. Okay.
Paying attention, Mr. Contract.
Hey guys. What's the area of this triangle down here?
L times W.
L times W. Yeah? Okay. Let's look at the big one. What's the area of this one?
4L times 4W.
4L times 4W. Wait a minute. Could I simplify that? What happens if I simplify that? What is 4 times 4? Isn't that 16LW? Can you guys see it?
Yes.
Okay. Guys, listen. I said that the ratio between the two triangles is 4 to 1, which means if I put 4W over W, I get 4. Yes? What happens if I put the areas of the large one over the small one? That's 16LW over LW. What happens to the LWs? What is the connection between a 4 and 16? 16 is 4. 4 times 4, which is 4 square. Guess what? If you know the ratio between the two objects, and you want to know the scale factor or the ratio, it's just the square of the factor. So guys, if I go back and I say, guys, this guy right here is 25 square units. What's the big one?
100 square units.
100 square units. Because it's 4 times, actually not 4 times, it's 16 times. So you have to take 25 times 16, which is what, 400?
Yeah.
So it's actually 400. It's not 4 times, it's 16 times. It's 4 squared times. Because the scale factor is 4. Okay, so a problem that is going to be like your homework. It says the radius of one circle is r. And the radius of a second circle is 3r over 5. What is the ratio of the areas of the first circle to the area of the second? So the first circle has a radius of what? What's the first circle radius? R. Second one is 3r over 5. So, what do we do with these? First of all, they're similar because they're both circles. What's the scale factor then between these two? It's not r. It says big first one to the second one. So first one over the second one. So guys, set up your scale factor. R over 3r over 5. That's the scale factor. The scale factor. Wait a minute, do I like dividing by fractions? Do I like that?
No.
So I'm going to do r times 5 over 3r. What happens to the r's?
Cancel.
So I'm left with,
5 over 3.
there's your scale factor. So if that's my scale factor, the question's not asking for the scale factor, it's asking for the ratio of the areas. What do I do with that scale factor? No.
Substitute.
No. We're not going to do those. What? Back. You're going to square it. Take the answer, square it. What do you get?
Square it.
25 over 9. The ratios are 25 to 9. Your homework for Lesson 5, Day 4 is 6, 15, 16, and 17. Have a great day.